Hi guys. So guys, in this video, we'll be implementing one amazing project called automatic traffic safety. So this is going to be one computer vision related project. So here we'll be performing something called object detection. So let me tell you about the project, what we are gonna develop here. See, I think you already know in some of the country, they use automatic traffic management system. That means what happens actually, beside the roads, they will be attaching actually lots of CCTV camera. And that CCTV camera will actually keep on tracking, let's say, road activity. That means whether a person is wearing helmet or not during riding the bikes. Okay, if they're not wearing, so what this system will do, it will automatically extract the let's say license plate number. That means the license plate information, and based on that, actually they will fine the money. Okay, to that rider. So these kinds of system actually most of the countries use nowadays. So here we'll be implementing similar kinds of actually system. So here we'll be implementing similar kinds of system. That means what I will do here, I will use some real-time custom data. With that, I'll be training one, let's say, object detection model. And that model will be able to detect whether any person is wearing helmet or not during riding the bike. Even it will also, let's say, detect what kinds of, let's say, vehicle they are riding, whether it's a, let's say, bikes, whether it's a car. Okay, so these kinds of actually vehicle also it will try to detect. Even it will also try to detect the license plate. Got it? So this is the system actually we'll be developing. So if you are completely new to this computer vision field, and if you don't know about object detection, no need to worry. In my YouTube channel, I already created lots of content related object detection. You can watch those recording. You will get the entire idea. So what we'll do, guys, let me first of all show you the dataset from where actually I'll be using the dataset and how this dataset looks like. So guys, if you don't have the custom data, so what you can do, you can use one amazing actually platform called Roboflow Universe. So let me show you Roboflow Universe. So this is the actually product of Roboflow. So I think you already know about Roboflow. Roboflow is a computer vision platform. So here you can perform all kinds of computer vision related tasks. So it is having one product called Roboflow Universe. So Roboflow Universe is having all kinds of computer vision related data, whether it can be object detection, classification, segmentation, key point detection. Okay, all kinds of data it is having. Now let's say you want to perform object detection and you want actually data. So what you can do, you can filter out this object detection. Even you can also search here. Let's say what kinds of data you need. Let's say I need let's say helmet. Okay, anything, just search here. Helmet, vehicle detection. Then you can also search about, let's say, then you can also search about road safety detection. Okay, these kinds of actually search keyword you can search. Now you'll see different data set would be there. Okay, now what I will do, guys, I'll be using one data set from the Roboflow Universe. So this is the data, guys, called helmet computer vision project. Okay, this is the data name. So I'll give the link in the description. From there you can download the data. Now if you want to use this data, guys, what you have to do, simply you need to click on the download project. And again, I'm telling you, guys, if you're using Roboflow Universe data, you don't need to annotate these are the data. This data is already annotated. This is the best advantage here. Now let's say you don't have the annotated data. So what you have to do, you have to manually annotate those data, and it is like very time-taking task. And how to perform the annotation with the help of Roboflow platform, I already created one tutorial in my YouTube channel. You can go ahead and watch that. So guys, now if I show you the data, it is having actually three classes called helmet, license plate, and motorcycle list. Okay. Now if I show you the image, so this data is already annotated, as I already told you. So let's open up one image here. Now you can see they have annotated the motorcycle, the entire vehicle. Even they have also annotated this helmet. Okay, even they have also annotated this license plate. That means three kinds of label we are having in this data. Okay, and I think this is enough for me if I want to perform this kinds of automatic traffic management system, traffic let's say safety system. Now if you want to use this data, just simply click on the download project. Now you can see one option called download dataset. Okay, now if I click here, now it will suggest me different format. Now here I'll be using YOLO V5 object detection model. So I'll be selecting this YOLO V5 PyTorch. Okay, this is the format. Now either you can download this data as a zip file, either you can download as a source code. Okay, let me show you the source code. So this is the code actually it will suggest. You just need to copy and execute from your notebook. It will automatically download the dataset. So for you, what I've done, guys, I have created one notebook. You can see this is the notebook I have created. So now let me connect this notebook, and all the resources would be available in the resources section, in the description section. From there you can download and you can use it. And make sure, guys, you have selected runtime as a GPU. So here you can see I have selected runtime GPU. Okay, so now let me connect. So guys, as you can see, my notebook is connected. Now the first thing what you have to do, guys, you have to clone the YOLO V5 repository. So this is the YOLO V5 repository. Let me show you. In my YouTube channel, I already created the tutorial related YOLO V5, how we can use YOLO V5 for the object detection task. You can check it out. So you can see this is the GitHub of the official YOLO V5. Okay, and with that we can perform the object detection task. So simply what I will do, I'll just try to clone this repository. So let me clone. Then after that you have to install the requirements. So it will have one requirements file. Let me show you. So requirement.txt file it is having, and inside the requirements you are having all the package. Okay, so these are the requirements you have to install if you want to use YOLO V5. Now let me install all of them. Now see, if I refresh, see YOLO V5 has been cloned. Now I have to install these requirements. Okay, now for this you have to execute this cell. Now let me execute the cell. So it will install all the requirements. After that it will show you the version of some of the package. Okay, that's it. Okay, so execution is completed. Now the next thing, guys, what I will do, I will install Roboflow. Okay, Roboflow, because here I'm going to use Roboflow Universe to get the data. So for this I need to install Roboflow. So let me install Roboflow. Okay, fine. Now simply what you need to do, just copy the link, copy this code snippet and try to replace here. Okay, now let's execute. See, it will automatically download the data here. So see, guys, my dataset is downloaded. You can see inside helmet folder, training, testing, validation. See, all the data have been downloaded. Now if I show you the YAML file, so here you are having 3 classes. Okay, as I already told you. Now you can also open up the image. You can also see. So let me open some of the image. Let's say this is the image. Now if I show you my project working directory, so I'm inside YOLO V5 folder right now. And if I show you my data location, so this is the data location. Okay, so make sure you are inside YOLO V5 folder. Okay, because YOLO V5 folder will be my root folder. And now if you want to see the data.yaml file, you can execute the cat command. So it will show you the entire data.yaml file. Okay, what is the content inside that? Now I have to load this data.yaml file and I have to extract the number of classes. I think, remember, it is having 1 NC classes. Okay, here that means 3. So this thing I have to extract. So for this I'll be executing this code. I will see number of classes would be 3. Okay, now here what I have to do, I have to use one configuration, that means model configuration. So here we'll be using YOLO V5S model. So it is available inside YOLO V5 models. Now you can see YOLO V5S. Okay, so this model actually will be using. You can also use L model, X model, okay, M model, it's up to you. S model means this is the smallest model. Okay, you can also use any other model, it's up to you. Whatever model you are using, with respect to that, you have to select this YAML file, and it is having all the configuration related to the model. Okay, now see, I have to change this NC parameter because I'm having only 3 number of classes, but it is having 80 classes because it is a pre-trained model. Okay, it's a pre-trained model on the Coco dataset, and Coco is having 80 classes. Okay, that's why what you have to do, we have to replace this number. So how to replace the number? So this is the content of this YAML file. You can see. Now if you want to change it, you have to execute this line of code, and whatever content you can see in the YAML file, I just copy pasted here, and only I'm just changing this NC parameter. Now see, if I execute, so it will automatically write that file in the model again. Now see, if I show you, now see, this is the file it has created, custom YOLOVS.yaml, and now you can see NC parameter has been changed. Okay, now we'll be using this configuration. Now simply you can start the training. To start the training, what you can do, guys, you can execute this command. So there is a train.py file, you can see. Let me show you inside YOLO V5 folder, train.py. You have to execute train.py. Give these are the, let's say, parameter, image size, batch size, number of epoch you want to train. So let's say as of now I want to train 100 epoch. You can also increase the epoch size as per your requirement. If you want to get a good model, you can increase the epoch size. Here I've given 100 because I want to show you only, that's why. Now pass the data location, so it will automatically pick up the data location. Okay, so from the data.yaml file, because you can see data.yaml file contains the data location. If I show you, this YAML file contains the data location. Okay, like where your image is present. You can see inside test folder image is present, inside train folder image is present. Okay, it will show you the entire image location. Now you have to give the model configuration. The configuration we have created, I think, remember this configuration path I am giving. Then I'm also giving the model name I want to use. I want to use YOLO V5 s.pt model. This model would be automatically downloaded from the internet. Then this should be the output folder. Okay, that means inside that folder all the artifacts would be saved. Now see, if I start the training, if you're using YOLO V5, it's very easy to use. So guys, as you can see, my training has started. It has loaded my data. Now see, epoch is running. So you can see, so my epoch is running. So what I will do, I'll pause the video. Once this training is completed, I will come back. So guys, as you can see, my training is completed and it has saved all the artifacts inside a runs folder. Inside runs folder, it has created one folder. Let me show you. So inside runs folder, it has created one train folder. Inside that, the folder name I have given, YOLO V5S result. Inside that, you will see your weight. Okay, this is going to be your weight, guys. Now let's download this weight because I'm going to create one web application. And for this, I need this weight. So let me download this weight. Make sure you're downloading base.pt. Okay, this is your trained model. Now you can see it has also saved some of the artifacts like your validation loss, your complete results it has saved. Okay, now if you want to visualize them, what you can do, you can execute this line of code. So see, my model has downloaded. Now let me, now see, it is having one result.png inside that folder. I'm just rendering it. Let me show you. So this is the complete like evaluation metrics actually will be getting. See, this is your losses. That means as per your epochs is increasing, loss is also decreasing. And this is your MAP score. That means mean average precision. And epochs is increasing. Your accuracy is all increasing. That means your learning is better here. Okay. Model is learning good. Now what I can do, I can show you some batch images. So these are some batch images you can see. Okay, so these are some batch images. Now let me show you some augmented ground truth as well. See, YOLO V5 internally, automatically it will perform the augmentation. Okay, you can see some of the augmentation technique it has applied. Okay, different augmentation it has applied. Now, if you want to test on top of your test data, so simply give the test data location. So this is my test data. Inside image, I'm having all the test image. I'll just copy the path. And here I'll just try to mention source is equal to your test images path. That's it. Now simply execute this line. So there is another file called detect.py. So inside detect.py, all the code they have already written, like how it will load the model, how it will detect, everything they have written. Okay. All you just need to execute and make sure you are giving your model location. You can see this is my model location base.pt. Now if I execute, it will perform detection on top of all the images and it will save the results. Okay. In the runs folder again. So let me show you. Okay, done. Now if I open the detect folder experiment, inside that you will see all the results have been saved and this is the detection, guys. Okay, see, that's how we are getting the detection. Helmet, motorcycle, as well as the license plate. Amazing, guys. Although I trained only 100 epochs, but detection is pretty good. Now what I can do, I can also show you the detection. With the help of this code, it will automatically take all the image and it will render, okay, on the Colab notebook. So see, this is my rendered results. Okay. Now what I will do, guys, I'll just try to create one web application. That means user will upload one image and they will get the detection. And I will also tell you how you can open up your web camera. That means let's say if you want to detect as a live camera, you can also do it. So for this, what you have to do, you have to clone one repository. So this is the repository, guys. I'll give this repository link in the resources section. Even I will also add in the notebook. Let me add it here. So here I think I can add. Okay, this is the repository. I'll add in a text. Okay, so this is the repository. Okay, so make sure you are cloning the repository. So let me clone the repository. I'll copy the link, open the folder, and let me clone here. So git clone my repository link. So guys, you can see cloning is completed. Now I'll go inside the folder. I'll just write cd. That means change directory. YOLO V5 app. Okay, now I'm inside this folder. Now let me open up this one. Now see here, just try to remove this YOLO V5 folder. Okay, because I'm going to clone newly because this is my old one. Now I have to clone newly. So what I have to do, you have to, I think, remember. So there is one link. Actually, there is one command actually I had written. So copy the command and just try to execute from the terminal. Okay, completed. Now let me open up my VS Code here. Now inside YOLO V5 folder, you have to move your model. The model actually you have downloaded. So let me move it. I'll just cut it from here and I will keep it here. Okay, this is my model. Now let me show you. So I already created the template. That means the web template. So here I'm using Flask for this. You can see I'm using Flask. Okay, Flask. With the help of Flask, actually, I've created this template. Now just open the app.py file. So here I have already written all the route. So only you just need to change here the model. I think model name is fine. Base.pt. Okay, no need to change anything. Everything is fine. Everything is fine. So what I will do, I'll open the template file, index file. Okay, inside that I'm going to change the project title. So guys, as you can see, this is the project title. Now here I'm going to change the project title, or I can write automatic traffic safety. So yeah, everything is fine. Now simply what I will do, I will install the requirements. See, all the requirements you have to install. So for this, open up your terminal, and first of all you have to create one environment. So to create the environment, just write this command conda create -n, give the name of the environment. Let's say I will give traffic. You can give any name. Then Python is equal to, let's take 3.10 -y. Now let's execute. See, it will create the virtual environment. After that, we'll be installing the requirements. So environment is created. Now let's activate. This is the command to activate the environment. Now I'm going to install the requirements. So just write pip install -r requirement.txt. So let's wait. Once installation is complete, I will come back. So guys, as you can see, installation is completed, but I will tell you one best practice actually you can perform. See, here we have newly cloned this YOLO V5 repository now. So inside that, see, inside YOLO V5, let me show you. Inside YOLO V5, you have another requirement.txt file. Okay, just try to open it up. And whatever package actually you can see here, just try to copy. Okay, try to copy all the package and open up my requirement.txt. So the app actually you have cloned from my repository. See, this is the requirements. Now what you have to do, see, from here, from base actually, just try to select everything and delete and try to mention here. Okay, that's it. Now let me save and let me again install the requirements, because this is the old requirement I was using. Some of the error actually you might get, that's why I'm installing the new one. Okay, that's the thing. Okay, so execution is completed. Now let's launch our application. So let me launch our application, guys. So I'll just write python app.py. Now let's give the allow permission. Then I will open up my browser and search for localhost 8080. Okay, now you can see this is the front end of our application. Now here you can upload the image. So let's upload one traffic image and click on the predict button. You'll see that you will get the detection after some times. So here I'm getting one error, guys, called proxy path on your system. So guys, if you're facing that error, what you have to do in the detect.py, let me show you. In the detect.py, you have to add this code snippet. Okay, if you're getting that proxy path issue, you have to add this code snippet. After that, just try to save. And now let's execute our application. So now I'll come back. Now it's running. Now let's upload the image and do the prediction. Okay, now see guys, here I got the detections. It is detecting the motorcycle helmet as well as the license plate. Okay, and now if you want to open the live camera, what you have to do, just give /live here. Okay, /live here and press enter. It will automatically open up your live camera. Okay, so all the functionality I've already written in the code. Let me show you in the app.py. So here I've given another route called /live. So it will open up your live camera. You can see source is equal to 0 I have given. Okay, so as of now, I'm not going to open up my camera, but if you want to open up your camera, you can do it. Okay, and the complete code actually I will share with you. You can execute the same code as it is. Okay, so yes guys, that's how actually we can perform this automatic traffic safety detection.